Good afternoon, audience. Firstly, I would like to thank you for taking some time to visit our presentation. We are Team Rocket, and these are our members, and we are from IT College East. Sorry, can Amizan actually control the slide?
I don't think so. I can.
Hold on. Hey, I'm sorry, ma'am.
If Wenchun-
Won't you say he's been inside?
Yeah, I'm here now. I'm here now.
Okay, Wonchun, can you control the slides? Or is it still Amizan?
I don't think I can control though.
Okay.
Okay. Should I just restart? Let me restart. Okay. Okay. Good afternoon, audience. Firstly, I would like to thank you for taking some time to visit our presentation. We are Team Rocket, and these are our members, and we are from IT College East. Firstly, I'll be talking about the problem statement presented to us by our school. Currently, students with severe multiple disabilities are challenged to communicate their thoughts, needs, and feelings. Additionally, they might not have the fine motor control to tap on a digital screen or the strength to press a mechanical button. Hence, we require communication buttons that are easy to activate and can be used to communicate in response to questions. As a team, we came up with a low-cost, low-power system on a cheap ESP32 microcontroller that comes with touch sensors. Persons with severe cerebral palsy due to their weak muscles have difficulty interacting in classrooms settings with mechanical push buttons. The touch sensor will replace the push buttons as no force is required to activate it. The ESP32 also comes with Bluetooth capability. When the user touches the touch sensor, the response is sent to a mobile device with text as well as audio feedback. This added feature removes the need of the teacher to be close to the user. Our proposed solution will allow users with severe cerebral palsy to interact and respond in class easier by making what would otherwise be difficult to press push buttons to a touch sensor as described above. This is an example video of our product.
The material used are the ESP32, copper plates as well as the enclosure. For the software, we are using the NRF, which is used for testing the Bluetooth connection. The Arduino programming software is used for programming the ESP32, while the App Inventor is for the Android app development. For the two copper plates in the enclosure, one is connected to the GPIO12, is for the right side touch sensor for yes, and the other GPIO4 is for the left side touch sensor for no. This is the circuit diagram, and on the right side is the physical connection. ESP32 has both the Bluetooth Low Energy and Legacy Bluetooth, which is also known as Classic Bluetooth. It also has 9 numbers of capacitive touch sensors. This slide shows the comparison between Bluetooth Classic and the BLE known as Bluetooth Low Energy. And in this project, we chose BLE because our application only transfers small amount of data, requires only short transmission distance, low power consumption so that battery can last longer, and the sensor data is only for on and off. The touch button is just a piece of copper plate. It is low cost, no moving parts, therefore no wear and tear, simple wiring, and most importantly, no need to exert any force to actuate the button.
So now I'll explain about the sensing technology that we use, which is the capacitive sensor. When the finger touches the sensor, the plate capacitor is formed between the finger and copper plate as shown. Its equivalent capacitance is connected to the touch pin, which will increase the capacitance on the touch pin. This slide shows how the touch sensor works. When the finger touches the sensor, capacitance increases, the charging will be slower as shown in green waveform below, which causes the pulse count to decrease. When the finger leaves the sensor, capacitance decreases. The charging will be faster as shown in black waveform below, which causes the pulse to increase. We tested out different copper plates to find out which is better. So we end up using the copper plate on the left, which is more sensitive as the pulse count is lower when touched.
As you can see on the screen, this ESP32 is a server and the mobile phone is a client, and it's the one-to-one communication. As shown in the previous slide, the BLE server announced its presence by sending advertising signal and ready to accept connection from the client. The BLE's client discovers and listens to BLE's devices that are advertising. That means the BLE client initiates the process of establishing a connection to the BLE servers. All we have to do is to open the AWA app and enable the Bluetooth so that the client can scan for the AWA server. To initiate the connection, we select the AWA server and to start the connection.
Okay. In this video, the NRF Connect app is used to test the Bluetooth connection. In the app, it will show the details of the UID and the property notify, which is here. I'll explain all this in the next few slides. The value shows yes when the green button is touched and no when the red button is touched. The UID is unique for the client and server. UID stands for Universally Unique Identifier. We generated a 128-bit UID address from this online UID generator. As shown in the video, the property is set as notify. We chose notification mode as it does not need to be acknowledged, so they are faster and a more efficient way to read data continuously by the client. This mode is used when the server wants to inform the client of a change in the variable, such as when the button is touched. As you can see in the video, every time the variable changes in value, the new value is automatically displayed on the mobile phone. We have come to the end of our presentation. Thank you for listening.
Thank you for your presentation, Team Rocket. Maybe I would just like to kick off the Q&A section by asking you guys about how, whether you have any plans to further develop your product.
I think we can make it a bit more like aesthetically pleasing for our buttons, for our touch sensors and stuff like that. But I think on the programming side and the wiring side, everything's alright already.
Oh, when you say like aesthetically pleasing, you mean like different designs? Is that what you mean?
Yeah, because we've been told by our school that some kids and students are afraid of the buttons. So we're thinking of maybe if you can put that touch sensor into toys or something more kid friendly, so it'd be more like accepted by the kids and students.
Okay, thank you for sharing. Do you guys face any like major challenges working on this project, whether it's the programming or anything? Yeah.
One of the, I think, biggest challenges was definitely COVID. COVID definitely affected us. The pandemic made us not able to meet up more often in real life to work on our product. And we also could not visit our school to meet up with the teachers and the students there.
Oh, okay. Yeah, I think this situation has also been quite hard on a lot of people. Maybe one last question. What was your team's biggest takeaway from working on this project?
I think personally and as a team, our biggest takeaway was that we didn't want to take any of our knowledge and our dreams for granted. So I think we need to understand that other people out there are facing different challenges, and we also need to help those people as well.
Thank you for sharing, and thank you for your whole team for presenting.